So we're quickly going to do one example from 1.2. Basically, it's just combining like terms, and then we're going to move on to 1.3. So for this first question is to simplify the expression, and you notice there's two parentheses here. The first step, remember, is you're going to have to distribute the integers that are being multiplied to the parentheses. So I have, let me rewrite this, 3 times 2q plus r plus 5 times quantity 4q minus 7r. And this 3 needs to be distributed to both here. So that's going to make 6q plus 3r. 3 times 2q is 6q. 3 times r is 3r. And then I'm going to distribute the 5 to both things that are inside the parentheses. And that becomes 5 times 4 is 20q. And 5 times negative 7. So this is a positive 5 times negative 7. That's going to be a negative 35r. You can multiply the integers with the variables. You cannot add or subtract unless they're like terms. So for example, in this next line, I have 6q cannot be added with 3r. You have to add it with the other q. So 6q plus 20q is equal to 26q. And 3r plus 35r, 3r minus 35r, so they're different signs, which means you're going to subtract the two. 35 minus 3 is really what you're doing. So that's going to be 32, but the larger number was a negative, so it's going to be negative 32r. And that's the simplified form. Okay, on to the next one. Okay, so we're moving on to 1.3, which is solving equations. And first we're going to talk about writing the algebraic expression. So for these first two examples, it's still just an expression. There's the expression written verbally, and we need to write it algebraically. So 2 more than 4 times the cube of a number. What I've done is I've rewritten it over here so I can make some marks on it. Because what I like to do a lot of times is cross things out as I get them, as I understand what it means and what it represents. So the unknown is your variable. The unknown is a number. I know it's a number, but I don't know what number it is. 2 more than 4 times the cube of a number. Well, I'm going to use a variable x for that. Okay, so I'm starting with x. 2 more, and then once I cross that off and use x, now I'm going to read the same thing over again. In place of a number, I'm going to say x. 2 more than 4 times the cube of x. We'll have the cube of x. Okay, so 2 more than 4 times x cubed. 4 times x cubed, I'm multiplying 4 with x cubed. And to do 2 more than that, that's going to be adding 2 to it. So I have 4x cubed plus 2. Okay, so for this second one, the quotient of 5 less than a number and 12. Well, again, let me cross this off and write x. The quotient of 5 less than x and 12. Well, quotient means it's a division problem. It's going to be a fraction. We're going to write it as a fraction. And what distinguishes the numerator from the denominator is this and. So it's 5 less than x in the numerator and 12 in the denominator. 5 less than x is not 5 minus x. If you're taking 5 away from x, that would be x minus 5. That would be 5 less than the number x. So that's one mistake too, because the 5 comes first in the words. A lot of people do 5 minus x. But if you pay attention to the words, and it's saying 5 less than x, you have to take 5 away from x. So in these next ones, we're getting to the equation and we're going to write the sentence like the question was in the previous one. So we have 6x equals 72. And because it's an equal sign, the key word with that equal sign is going to be is. 6x is 72 is basically what you want to write. So what's happening between that 6 and the x is they're being multiplied. So we're going to say 6 times the x is going to be a number. 6 times a number is 72. Okay? And this next one is n plus 15 equals 91. Well, how we're going to write that one out is we're going to say, what are you doing with n? What are you doing with a number in order to get it to be n plus 15? You're adding 15 to it. So that means 15 more than a number is 91. So now we're getting to actually solving the equations. And again, these first two are just one-step equations. Probably nothing too difficult for you, but we're going to do number 5 first. N minus 12 is equal to 35. So I'm trying to solve for n. So that means I got to get n by itself. Well, what's happening here is I'm subtracting 12 from n. So remember, we need to do their inverse operations. The inverse of subtracting, or the opposite of subtracting, is adding. So I'm going to add 12, but that means I also need to add 12 to this side. So these two will cancel out, and that's going to become 0. So then I have n is equal to, and this becomes 5 plus 2 is 7, 3 plus 1 is 4, n is equal to 47. So I'm trying this out, and I made a mistake, and I'm trying to fix it, and we'll see how it goes. So when I have this type of problem, normally I would divide by negative 5 over 8 to both sides, because that's what's being multiplied to my variable. Well, in this case, it'd be dividing by a fraction. So instead of dividing by a fraction, we're going to multiply by the reciprocal. So the reciprocal is going to be negative 8 over 5. And I also multiply this side by negative 8 over 5. So what I need to do is multiply straight across. And the reason I multiply by the reciprocal, because what happens when I multiply by reciprocals? Well, negative times a negative becomes positive. 8 times 5 is 40. 5 times 8 is 40. And what happens there is that becomes a 1x. You don't have to write that part, but that was the whole point of multiplying by the reciprocal, was to make that 1x. So I have x equals, and what I can do here, make this 20 over 1. You can multiply straight across, but sometimes it's going to be a lot easier if you understand that you can cross reduce. And all it is reducing, except it doesn't have to be in the same fraction. As long as something's in the denominator, can reduce with something in the numerator, that's okay. So I can cross off this 20 and 5 because they can both be reduced by 5. That makes this a 1, that makes this a 4, and 4 times negative 8 then becomes negative 32. 2 times 1 minus x. So that's going to be 2 times 1 is 2 minus 2 times negative x. So it's positive times negative. That's going to be negative 2x is equal to 14. Now I can combine my like terms. So have the 5x, negative 2x, that's going to become 5x minus 2x, which is 3x. Positive 15, positive 2, that becomes positive 17, and is still equal to 14. Now I can solve it just like any other equation, and I'm going to subtract 17 from both sides. So that's 3x is equal to, and basically I'm subtracting 17 and 14. They're different signs. One's positive, one's negative. The difference is 3, and it's going to stay negative because the larger number was negative. And now I need to 3 times x, so I'm dividing by 3, and x is equal to negative 1. Okay, so here are some U-tries. The first two, the first one, write the verbal sentence as an algebraic sentence, as an algebraic expression, I'm sorry. The second one, write the algebraic expression as a verbal sentence, and then solve the next two. I'll give you the answers here in a little bit, but first, you get your joke. You guys are going to love this one. This is a good one. So, why do you have to be careful when it rains cats and dogs? Because you got to make sure you don't step in the poodle. That's awesome. All right. So the answers are here. The first one, x cubed plus 4x. The second one, 5 less than a number is 2. Number 3 is negative 27. Number 4 is negative 1. So if you got any of these wrong, make a note by it. We'll talk about it tomorrow. And have a good night. Don't forget to check the website and the syllabus, and have your parents sign the syllabus contract if they haven't already. Have a good night.